Hello everyone. Today I will show you how to do the curing simulation. So once you will open your console, you will come to this window. Right? So here you will select the model wizard. As we are addressing today for 2D geometry, I will basically go for 2D geometry. Then you can explore for 3D geometry as well. So I will select for 2D geometry. Then here we need two physics. One is heat transfer in solid, as our temperature is also one parameter, and we have some algebraic equation, right? So for that domain ODEs and DAs, as I have already used these models so many times, that's why it is showing here recently used. Otherwise, you can search here whichever model you require, right? So heat transfer in solid, and then you can go to search. So it will automatically come. Otherwise, see if you go heat transfer. So under heat transfer, you will see heat transfer in solid. So you have to select, then add, right? So while adding, you can read these basics also, how heat transfer in solid model works here. Yes. Similarly, you can add the another model domain ODEs and DAs that you have to search here. But I have already used. So under mathematics, it will come ODE and DA interfaces. So you have to select that, then add. So here we have dependent variable is degree of cure alpha. So we'll replace U with alpha. And our depend this quantity is already dimensionless, but the source quantity term has units of frequency, that is hertz. So we'll go to editing mode of this unit under general. That's this. So this you have to select and then OK, right? Then go to the study. As our study is time dependent, I will select time dependent here and then done. That's it. So it will ask for saving. Anyway, later on I can save. Otherwise, you can save it. It will take some time, I think. So meanwhile, you can read this what is in how it works for time dependent. So that's so here. Initially, we'll add some parameters here. So I already have the parameter window. I think I didn't open it, but I will open that file also because I can again directly copy and paste. Else again I need to write all the parameters, right? But for your model, you can add all the parameters here according to your convenience. So if I want to add the expression like thermal conductivity, suppose K0. And some unit I need to mention, so bracket watt per meter per Kelvin. So like this value will appear automatically here, watt per meter Kelvin, and some description. Now what is this thermal conductivity? So like this, you can add all the parameters, right? So once my file will open, I will copy paste here. Right? Then we'll go to the geometry window. So here we have to draw the geometry. So 2D geometry we have selected. Once my window has been opened here, so I will copy paste that data. So all these parameters I have already added. That is, this is heat of reaction, total heat of reaction, frequency factor. These more values I will require for solving the physics. Right. So all these are the parameters. You can go through it. Now come to the geometry. So under geometry, you can right click and add whatever you want to. Else, you can also go to this domain geometry. You can sketch whichever geometry you want by your own. Else I can go to simple geometry rectangle I will draw. So under this rectangle, it will ask for width and height. So 1 meter by meter is very large, but okay, I will go for 0.1 meter and the height will be 0.05 meter. Okay, and then build. So this rectangle has been created. Okay, now we'll go to the material. So we have to add the material here. Yeah, so we'll go to the materials, add blank material. So the values are automatically coming in: thermal conductivity, density, heat capacity. So in the parameter window, I have already mentioned all these values. So I just have to these names I have to just insert there. So thermal conductivity I have mentioned by kg. Density I have mentioned by rho 0. Oh, so what is missing here? What kg I have written? Oh, small k and 0 I have written. Okay. Not capital K. That's it. And the capacity CP 0. So once it is correct, it will show the green mark. And these parameters are in the domain, so that I have selected. Now we'll go to our physics, that is heat transfer in solid. So this is our solid domain. So here you can see, go for equation, modeling. We can explore all this. Okay. So whatever the parameters, that is thermal conductivity, density, which is from the material, that is already selected here. Now initial values, the temperature here it is taking 293.15 Kelvin. You can give whatever the initial temperature you want to mention, like 350 Kelvin or whatever it is. Then thermal insulation is directly coming from all the boundaries. But we have here model temperature, mole temperature that we have to add. So I will add the temperature domain here, and this is for the all boundaries, and that I will give to, like, suppose 360 Kelvin. This is my mole temperature. That's mole temperature of all the boundaries. Again, I need heat source term also. Heat source. So I will right click and I will add the heat source. So in by default it takes general heat source, but here we have user defined. So equation is there. So it's minus h underscore heat of reaction into d alpha by dt. So d of alpha comma t. This equation I have already written properly, so I will note down here minus rho 0 into h underscore r d alpha by dt. Sorry. So this is coming watt per meter cube, right? And yeah, see here it is showing red mark. Why? Because selection is empty. We didn't have selected. So we have to select for the domain. Right. Now the right. So now we will go for domain ODEs and DAs. So distributed ODE. So here, this is our D alphabet dt term. We have to add the equation. I will add from my another source. So here we are using nth order model. You can use Kamala's Soros model, whichever you want. You want to simulate for your geometry. Okay. So here I will. These all things you can explore, like the article I have shared now, you can go through it, otherwise you will not understand. It's just a demonstration. Now initial values alpha is 0, d alpha by dt is also 0. That's it. Now we'll go for the meshing. So here you can explore all the mesh, whichever mesh you want to create. Initially I'll just go for normal now and build all. So this is a very coarse mesh. This is normal mesh. Here you can user control mesh. Here also number of factors are there that you can explore. So there are number of tutorials on how to create geometry as well as how to create meshing. You go through it. You explore all this. These are very important phenomena, but this is not the video for this. That's why I'm not mentioning here. Okay. Done. We are done. So now we'll go to study. Under study, you will see time dependent. So here you have to select the unit, whichever you want. Initially, just for the few seconds, like I will select for second only. It will take time definitely. So you can select minute or whatever you want. And this is 0 is initial value, that is starting from the 0 second. This is 0.1 is a step size. So I will select here as 1 second. And the final value that I want to run it for 10 seconds. Definitely for within 10 seconds I will not get the result. But this is just a demonstration, so I will select the 10 second. Hope it is running, or may it take some time also. So like this results tab will come. So under the results, this is the temperature. This is for 10 seconds. So there is not much difference now, because see at the boundary only within 10 seconds how much temperature. Otherwise here also you will have the like around 360 Kelvin. Huh? See at the boundary only it is showing now 360 Kelvin. Inside it is 300 only. Isothermal contours. So this you can explore. This 2D plot group 3 is degree of cure. So see 0 to 10 power of minus 24. And our target is to reach the value 1. So you can imagine that how much time will it take for running the simulation, right? So this is not the complete simulation, but just for the sake of your convenience and sake of our understanding, I am showing this. So now see, these are the control plots. Now if you want to do the one-dimensional plot, then what you can do? You can add here cut point 3D under data set, right click cut point 3D. So you can add the coordinate at what point you want to do the one-dimensional plot. So here midpoint I will select 0.05 and 0.03 also I can select. Why it is showing 3D? Ours is only 2D geometry. Oh, I have selected cut point 3D one. Ours is 2D geometry, right? Why there is need of 3D then? We need to select cut point 2D now. As our geometry is 2D. If your geometry is 3D, then you can select for 3D. Yeah, so coordinates x is 0.05 and y I will select 0.03. Plot. So at this point I will plot the one dimensional. So under results, right click 1D plot group. So under 1D plot group, go to point graph. Under this point graph, data set, which one is cut point 2D1. So by default it is coming temperature Kelvin and the parameter is in second. So if you want to Plot temperature versus time, plot it. Yeah, these are not the results properly, see, but how to do it, that's what I am showing you. Now, if you want to plot alpha versus t, that is degree of cure versus time. So here this domain, domain ODs and DAs alpha and plot. So alpha versus time. So like this, some plot will come to you. These are not the proper results. Okay, I have just shown you. Yeah, that's it. So like this, you can simulate your file.